journey of exchanging ideas with like-minded people around data quality, governance of data, structuring and cleaning thereof, and management of data is exciting. Research and development on the latest methodologies and technologies in the field of data analytics, augmented algorithms, machine learning, artificial intelligence from a quality data hub will take MIT CDO to the next levels.
Good morning, everybody. Welcome to Track 5, Leadership in Action, Lessons Learned, Success Stories. My name is Bob Audette. I am a partner of data management at Guidehouse. Today's session is really focusing on CDOs as really strategic leaders for transformation in organizations that are really trying to innovate data and analytics. I think more specifically, the focus is on the fast, radical change of current digital world and emerging technologies, and such as quantum computing and value-driven data science, enabling practices and demands really CDO leadership and ownership within organizations to really tackle and embrace these new emerging technologies. A couple of housekeeping things. The presentation will be available in the symposium proceedings. The video will be available 3 months later on the MIT CDO IQ YouTube channel. Regarding questions, for those in the room, please raise your hand. Have the mic in your hand first before you pose the question. Otherwise, those in the virtual portion of this will not hear you. So if you could kindly abide by those guidelines, I would appreciate it. Feel free also, and those in the room, and especially those online, use the HOVA app to pose your questions. And I am going to briefly introduce our panel facilitator, Dr. Solomon, is it Jaeger?
Yes, De Jager.
De Jager. He's a CEO and president of the Pilog Group, and he has a really long and accomplished background, and I'm truthfully sharing some of the highlights because the background is quite extensive. And he's a repeat attender and speaker at the symposium, so thank you for coming back. And, he really had the vision that really data investments would really become the assets of the future. And therefore, the Pilog data was established to really focusing on tackling data issues, schemas, standards, and different types of data-focused solutions. He's defined and launched the Pilog Global Academy that's going to serve as a hub for different industry best practices, academic developments, focusing on mastering data issues. So with that, I'm going to hand it over to Dr. Solomon to continue with the conversation.
Thank you for the opportunity, Rob. And I'm privileged. I'm glad you started with, in 96, because I want to introduce the panel members here. And the first guy here is Wynand Nortje, who's part of the panel, but we have to leave somebody at home to guard it for us. So Wynand couldn't come, but he's part of this, and he'll pose some questions, and we'll cover, and we'll look at some of those questions, and get his input on it. But Wynand was actually one of the pioneers that in the 80s, I was with the opportunity to start a startup which developed the South African Air Force system, the Navy system in the 80s up to the 90s. And then we sold that company to British Aerospace, and we made a very, very crucial decision at that point in time. And that was the future is going to be data. So we got out of the ERP and the logistics systems. And since 95, we just focused on data. And the whole start of that, and I think that will come back, and that's where Wynand's background really comes into this, was we started taking the NATO templates, and that became the first sort of e-commerce system in the 2000s, and we commercialized that. And that drove a lot of data quality because you could put quality into the templates and then pass it on. So Wynand was really a pioneer in developing that. And later through the discussion, we can highlight the templates, but I think that is really cool to the whole discussion of quality data. And we, just like in mid-90s, I believe we are absolutely a next crossover. with quantum coming. And we're going to touch on some of those points. I think it took, and my first introductions to CDO was way back with John and them at MIT, and Larry English and Rich and these. It took us since the 80s, where are we, 40 years, to actually get from digital data to some better sort of stuff. So I hope with the quantum coming, we're not going to take that long because it's on us. So Wynand was a pioneer in getting us through that, developing it. But a small story which I think very few people know. When the English came to South Africa and they took our gold and our diamonds and so on in 1900s, right at the level, there was a war right in Natal where the Zulus beat the English one time, way back. And then there was a war one day. And that war, there was 3 prime ministers in the same war in South Africa. And the one was General Louis Botha, which is, of course, became Prime Minister of South Africa. The other guy was Winston Churchill. He was a reporter in that war. And the third guy was Gandhi. He was a medical stretch bearer. So with that, I would like to introduce Imad, because Imad, for the 20 years that he's been with Pilog, Imad is Pilog's Gandhi. Because he did a lot of changes, he did a lot of innovations, and therefore this whole changeover from the CDO role, into the next, I think we're in capable hands. So for Imad, since he joined us, when was it, 2003, 2004 with SABIC, the task where, the technology was not really there, integrating, was it 21 different plants?
Yeah.
1 million procurement items, different systems into one SAP instance in 2003. And data was all over the show, and we had to catalog all of that. So he cut his teeth in the practicalities, bringing that in. And for all of that work, I'm very, very happy that he got allocated or given, an honorary doctor's degree. So that's Imad. So that's where I want to stop with the introduction. And I think we need to get into the questions of the panel.
Yeah. Thank you. Thanks for that intro. First of all, thanks for this opportunity. MIT CDO has been special to us because we have been coming back here all the time. For the last 2 years, we couldn't, but we made it. And everybody, whoever is joining and listening in, thank you very much for your time, because we appreciate your time. So today's discussion is going to be split up into 2 different topics. One topic is on the quantum computing, where doctor will fly at 42,000 feet, and then I will drop to 36,000 feet, wherein I would be sharing some of the lessons learned, success stories, and also the prescriptive roadmaps for the CDOs. The reason why we split it up, because we need to always have a latch on to the innovation and technology, but also be very, very practical about what we are doing. From our vast experience, we are going to share some of the lessons learned and success stories that are purely focused on how other organizations could, transform their businesses successfully. So its first 20 minutes is going to be, we all will be flying 42,000 feet, because from that view perspective, where the quantum is going, what is it, and how the brain can be connected with the computers, all of that you are going to hear it from doctor. And then there are a lot of practical examples that I would like to bring in to be successful CDOs, because we have heard several buzzwords, and every year you have at least 50% of the new buzzwords coming in, and that can really distract you, that can really take you in a wrong direction. But from our experience perspective, we have got a recipe, we have got some of the pointers and directions that we would like all our CDO community to listen to and see what is realistic to implement. Okay, so doctor, The first question is, I know it's your favorite subject, quantum computing, and you are the first one to present it at CDO IQ last year about quantum computing, and this year we see 4 to 5 sessions on quantum computing. So you are pioneers there. So would you just give a brief idea about quantum computing, and also how is it relevant now? Are there any projects that are being realistic? And also the whole research that you are closely following, that how can the human brain can be connected with the computers, so that whatever we are thinking, that can be captured by the computers. So can you maybe talk about that?
I can, Imad, and thank you for that. But I want to just say, from South Africa, we've got a fellow South African who's really changing the world. And funny enough, we came from the same city in South Africa. And he's really into quantum, so it made it easy. What I was thinking, is actually latching on. That's Elon Musk. So a lot of the things that's actually coming to really is also from there. So that's easy. So if you look at the basics, and let me just cover quickly, because from last year and this year, I don't think everybody understands what quantum is. So if you do, forgive me for that. But to me, there's a next level that we don't really see. And I've got lots of discussions. I think John is in this room. And as I say, everything is frequencies. So, and I'm going to prove my point, because it is. So, and understanding that is where quantum is actually linking it. So quantum is going to be the next disrupt. So what data quality, a key issue in these algorithms that's going to drive it. So having said that, we just need to quickly understand, what is a quantum computer? So if you look at the top screen, that is a classical computer. And that is one state, it's either 0 or 1, and it's in bits. So that is as simple, and everybody is familiar. And if it took us 40 years, and there was a question yesterday in the quantum session, now where's the quantum operating systems, and the LEX and all these other systems that's going to build on it? And everybody say we're in a flux state. But if you take quantum, we need to bring in 3 different elements, which you see on the bottom one. And that is, quantums are actually qubits. And the difference between a qubit is not a 0 or a 1, but it's got a probability, and it could be anything in between. So that in between of a qubit drives a whole new dimension, which is superposition, entanglement, and interference. And I want to go a little bit into that so that you can really see why it's so important. So if you take superposition, that qubit could be, and this is the takeaway that really took me some shocking realization. Quantum could be, it's in all those states until you measure it. If you measure it, it realizes. Until then, it didn't realize. It is in all those states. That's why you get the speeds. So that superposition could be, if you measure it, it's 50% a 1 and 50% a 0. Or it could be 85% a 0 and 15% a 1, or 15% a 85. That's superposition. So that dial could be anywhere. And if we get to the implementations, that's exactly, if you can manipulate that, you can manipulate the whole probability where it is. So that's superposition. The next one.
So doctor, let me just clarify that. You are saying that there could be, between 0 and 1, there could be multiple permutations and combinations of states.
Hundreds.
So
bear with me.
Yeah, okay.
Bear with me on this. So check this one. So if you look at the entanglement, I think it explains the superposition a little bit better. Because entanglement means if you have one of those qubits, like on the top left-hand corner, and it's the one is at the 60-40 when you measure it, and the other one is at the 15-80%. The entanglement means that the moment you bring 2 quantums together, they entangle. And all of a sudden, you don't see the 60, 40, 15, or 80. You see exactly the entangled result. So if you measure it, and there's 2 there, you will get what you see in the top right-hand corner. So the fact that there's a 0-0 status could be 25%, a 0-1 is 10%, a 1-0 is 40%, and a 1-1 is 25%, because they're entangled. And if you take that and you take the dials and you can alter that, you can see this whole probability is always there. The full potential is there. But only when you measure it. So it's what Einstein also said, we're entering spooky stuff here, these something, and we'll get a little bit to that. So on the right-hand left bottom corner, you'll see if you have 1 qubit, you've got two states. 0 or 1. You've got 2, it goes to 4, 3, it goes to 8, 4, 16. So you've got n qubits, you've got n to the power n entanglements potentially. So that's why, and yesterday's question was, the fear for quantum computers is they're going to break our security and cryptics. Let's get that one out of the way. And from all this literature, and I must give credit, I think this is from the IBM stable, they really hit IBM, D-Wave. And this is coming from 3 December, Qiskit is the educational, and most of this, because it's so simple, I took it from there that we can translate it. But we around at 100 qubits, and they will say it will take many, many years. We actually need a million qubits to start cracking into. So there's some time. But I've got some other ideas on it. But anyway, so it is in progress, right? So this is entanglement. The third element there is interference. And this is where the kicker kicks in. Because a qubit is not a 0 or 1, but it is described by a quantum wave function. And it is a wave. That's why it's got the probability to be a 0 or 1 and oscillating in there all the time. And if you measure it, it takes a position. But if you've got 2 or you put 3 qubits next to each other, you've got 3 waves. And because of entanglement, the wave gets absolutely driven to 1, so it's an overall wave function. And waves, if you go into the whole wave potential, you've got constructive interference, you've got destructive interference, you've got noise, you've got all sorts of other stuff. And maybe this is where this spooky stuff started to interest me. In the 70s, when I was busy in my engineering degree with physics 3, the one day we got this thing that, and actually my mother said, atoms and so on. They will one day find out atoms are not, this electrons and protons and stuff. No, they're made up of smaller stuff. And really later it's quantum. It's quarks. And if you take quarks, it goes to quantum. Okay? And in those studies, you already had the whole position, and this just touching, but it's coming to this interference thing of Max Planck's particle in a box. No, just Google it. The particle in the box, it didn't follow the energy to get out of the box into another position. No, it tunneled through, and nobody could explain it. And I think we're getting to that. But enough of that. So that's interference. And I think these 3 principles is really the takeaway that I want to leave, because we need to get our minds away from 0, 1s and flat qubit stuff, bits into qubits. Okay. Now, where are we? Here's a couple of models. And I don't want to go into this. This really goes a lot. But if you have the typical classical computer, which is a gate, a 0 or 1, or NOR gates, that's what we got. And see, we're flying to the moon with that. If you take the quantum computers, you have some that are designed on the gate model. Some of the examples I saw yesterday from the IBM and so on. It's a gate model where they simulate actually digital, which is what you see on the right hand. Or you get one where it's measurement based. So you tweak this probabilities in the frequency and you measure it. Or some of them adopts this whole principle. Almost sounds like Genesis. At the beginning, everything was empty, because everything drops to the lowest energy state. So they apply that, which is the adiabatic quantum computing and look where the state in the system is the lowest and then measure it. And that's a whole thing. So you can see the adiabatic quantum computing, quantum annealing, and these are all different models, not two silica chips. It's a lot more than that. Other models, topological quantum computing. Interesting is the one on the left-hand side, where the guys are actually building quasi-particles out of atoms, electrons, and photons, and get a quasi-behavior out of that. And move, some electron plates and manipulate the noise or screening. So many models. If you look at superconducting, that's a typical model where they've got a frequency change in oscillation for pairs. Or the one that really triggered me is magnetic, because our brains are working magnetically. So, our sense of smell, so on, it's a frequency. But we have to put everything back to bits in order to get it, It's like music. When I was a student, it was vinyls. Then we got to this magnetic and discs, so I got rid of it. I got digital. Now my sons are back to vinyl. So we went from digital back. So there's a lot of oscillation, and I think we happen. So there's some realizations, linear ones. That's the topical computing. There's the physical realizations model that I've said. And linear computing models. Interesting, on these models, you can see it's linear optical elements, which are mirror wave plates, and integrated in photon chips. So they start building computers out of photons and experimenting with that, and look at the takes or the number of photons and the position. It's not sand. Okay. So some others, it's trapped, and so you can go on. It's really amazing. Trapped quantum computers, color centers, all of these models, the realizations of actually building today, are trapped quantum computers, color center computers. It's the neutral atoms in a particle, which are physicals. And so it goes on and on and on. And I don't want to wave it. I think you can see the potential is tremendously on this. What are we going to use it for? Actually simulating, because it can speed up creating new materials without all the time of that. And chemical reactions, the whole DNA thing, etc. You can speed this up with quantum computers to a tremendous lot, And Earth and these solar panels, improving new chemicals, and there's lots of stuff where some of these models are actually going. Okay. So you asked me about, now that we understand quantum.
Right.
Last year, our first presentation, which really triggered me, was this one, where the first time a guy could sit and think, which was a brain-computer interface, where the logic of the mind with neurological vibrational data encoded, into cryptical stuff, got actually measured on a computer. Now, 1 year later, coming back to Elon Musk. Elon Musk is the co-founder and starter of Neuralink. Why do you think when he started electric cars take on the industry, ran into battery problems, he couldn't wait, so he started getting into the battery business. Now he's got electric cars, self-driving, but he doesn't have the computing capacity. Now, if you think, if the computers does it, are the humans going to be able to cope with this? So they invested into this, where the human brain is connected to the internet with a device. And that device is really where you're going to interact, and they're busy with that. I think it's got a name. It's a PIC where they've tried this. And you can see it, they're working on it. And all of that will be human brain electromagnetic fields translated in the digital world, so that we can set, because I think we're in the hybrid state. Talking about Tesla, this is what came out in 14 February. The Tesla Jodo chip. So it's not a full quantum computer, but they ran into capacity. But it's a near quantum computer, and he already said this year we'll bring out a real quantum computer. And if you take it, calculations with normal computers that will take us 10,000 years, a quantum computing, because it's got all the states immediately, is going to realize that in 3 seconds. It's 158 million times faster than we are struggling right now. Okay, and that is why I say all of this is creating data. So if you look at that, and I don't want to go in, the Tesla self-driving machine learning, it's there. And there's software stacks for that. And it's all based on data. And driving, machine learning, and so on, and the Dojo computer chips is there, et cetera, et cetera. So, Imad, I think I've painted the picture.
Right.
I think we're there, and we need to do something. We can't wait 40 years again, before we get data quality into this stuff that's coming onto us.
Right.
Maybe I just want to finalize with this one slide. There's 1 or 2 questions. Let's just go on this one, and maybe this is making the better crossover, because I was checking our time and you gave me 20 minutes and I was going over, so I was trying to run this short.
No issues.
But if we take all of this and we think that information is something that's encoded in this quantum state, it's physical, because if we measure it, we get it. But in the quantum state, that is teleportable. So Scotty beat me up, and that stuff is not spooky stuff from the future like mobile phones I saw in 73, with Star Wars. Now we're there with all of this stuff coming, because quantum is teleportable. And the human brain, which is electromagnetic, is actually today, because we're in a crossover, we translate to digital. Like my example, we had vinyl perfect frequency sort of music.
Right.
Then we took it digital to get it cleaner and manipulate it. Maybe we lost some sound. I don't know. That's why my children, they want to go back to vinyl. Maybe we're in this phase. And my question then, what are the CDO guys are going to do with all of this?
Thank you, Doctor. I know, we were at 42,000 feet, and it's still evolving. From the CDO perspective, I think my take is that every conference that we attend, every year that we come with new technology or components, CDOs need to be aware of those, but not fully invest into it. Because the terminology is changing, the technology is changing, everything is changing. So, yes, we will be aware of the quantum computing, but probably we do not have to be ready with that, because by 2024, we would have some indications whether, the quality of the output that we are expecting out of it, whether that would be reliable or not, and how are we going to apply in which industries, because the use cases are different. In financial industry, it is something that would be very much applicable. And in the aeronautics as well, it's going to be applicable, where, the calculations are in higher volumes, but it might not be applicable in some of the other stuff. But again, supply chain is something, where you want to bring in disruption. That's also something that we can look at. So there are certain use cases that can be considered, but again, all of them are industry specific. So, my view is that probably we need to be aware of it, but we don't have to take action until we see the infrastructure that is available. IBM is promoting it. If somebody would like to play with it, they can play with it. But again, just to know, how it is, what it is, those are the basics of it. And there are still, 8 out of 10 questions that are not answered yet. So I think it is evolving.
Okay. And how can the CDOs, in your opinion, how can the CDOs influence this? Not waiting another 40 years, but be proactive. You've got any ideas of that? Using what we've got,
Yeah.
and bridging this gap.
Yeah. See, Doctor, I want to touch the topic of how the CDOs can be influential, or how can they influence the business transformation programs. Because I have heard on many sessions now that there are a lot of do's and don'ts and blah blah blah. But I would like to summarize that into 3 C's. Let me just go to this one. Maybe I would have taken the 3 C's. Any organization is looking for efficiency and effectiveness, and nothing more than that. Every organization is actually trying to improve the efficiency of their processes or effectiveness of be it bottom line, be it the top line, whatever it is. And organizational efficiencies are actually creating these programs, which is the digital transformation, business transformation, or you call any of the other transformation programs. So the big challenges that CDOs have faced is that first of all, the expectations are huge. We know of several organizations where they said that let's bring in a CDO and he will do the magic. CDO cannot do the magic because, again, the platforms need to be there, all the tools need to be there, the methodologies need to be there, and he must be given time as well. So we have seen that those CDOs have failed. Within a quarter or 2, they could not achieve it. So the first thing that we say is that you communicate. If let's suppose any organization is going through a change, and especially the CDOs need to communicate with the shareholders, communicate with the directors, as well as communicate with the business, and also all the bottom users of it. And every time they don't communicate it, and the change will not be accepted. Change will not be accepted by the people if you do not communicate. What is it that need to be communicated to the top level? Top level, we need to communicate what are those numbers that we are looking at, what are those functions that we are looking at, improving it, and what is the impact of that on the bottom line. So it's again a value engineering principle wherein either you improve the efficiency of a product or a service, or you reduce the cost. So either of them we have to do. So effective communication is important, and again that could be via the awareness, via the different things. I'll give you a simple example. One of the CDOs joined one of the large organizations in Middle East, and he has been thrown literally a hard disk of 1 terabyte and said that here is the data. I want you to transform this data and put it into the systems. Imagine that is how the nature of the thinking, with regards to the CDOs. What can a CDO do with that? No, we are going for a S4 HANA migration. Here is the data. I want everything to be sorted out, clean, govern. And how can a CDO do something? He had to leave after 3 months because what is there in that hard disk, nobody knows. Who is the owner of it? No, the guys already left. And who are the owners? The owners are those guys who have been working long enough in that organization. So that's the practicality of it, and that's the reason. And sometimes you do not communicate properly, and then there are expectations that built up. So in certain organizations, there were some cases wherein CDO walked into the organization, worked without a role, understanding all the business processes, because the moment you say that he is the CDO, everybody gets frightened. They do not want to share the information. Where are the data sources? What are those things? And everybody feels that we will be exposed because, we are not doing our job properly. And that's the threat. That's the thing that everybody is afraid of. So in certain organizations, they were smart enough. They said that you pay a visit to the plant, you pay a visit to the corporate office, you pay a visit to the associate office, and learn from all of that, and then come back, and then, you give us a plan whether you would be able to transform or not. And those CDOs could be successful, made it success. The reason for that is they learned, they understood what needs to be done, and especially the gaps and the value leaks is something that CDOs need to communicate. So I say that communication is important. That's the one. And then the second thing is coordination. And all the time, CDO, the moment CDO is coming, IT guys are scared. shit scared. They say that, guys, he's gonna now suggest something. We will have to do that because that's a mandate. If he is given mandate, by the way, and 8 out of 10 times, it's not giving mandate to the CDO that failed the whole mission, whole program. So coordination with the IT, coordination with the business, because CDO is only a transformation agent. He is not the guy who is going to do something. He need all the people around him, especially the business IT, to do the transformation of it. And then at the end of the day, it's the collaboration of it. And until and unless you collaborate with everybody, you won't be able to deliver it. So those are the 3 C's that we always suggest, that you do the communication properly, you do the coordination properly, and then you go with the collaboration of that. So, and apart from that,
So, Imad, what you're actually telling us is we won't get away from the basics.
Yeah.
So whether the source of this data is now coming from photons,
Yeah.
or the trouble that Elon ran into, that he get this massive lots of data, now has to store it somewhere.
Right.
In this hybrid state, what I hear is we'll have to bring it digital so that we can take our current tools, manage it, manipulate it, and then we're back to basics. Your example of, here's the disk.
Yeah.
I think that's what happened there. Here's the disk with all the machine, all the data, this car, whatever, sense it. Now do something with it and learn something with it and drive.
Absolutely.
So
Absolutely.
okay.
Absolutely. So the intermediate stage is, again, quantum. It should come. This is the decade of quantum. That's what everybody is saying. We will see that in a couple of years. But the intermediate stage is that, first of all, digitalize it, and then we can move to the next one. And just to touch on that, generally, what is the recommended roadmap or the strategies for the CDOs is something that has been asked several times. Let me just put everything. So, CDOs cannot jump to the conclusions. They cannot say that, okay, I understand this is what I assume, and let's move forward. CDOs need to do a proper as-is assessment. As-is identification first. Because many a times CDOs, when they walk into any organization, they don't know where is the data, what are the data sources. Probably the data is sitting on somebody's desktop. Probably the data is sitting in the archive folder somewhere. So they need to do or identify it's a discovery process of as-is data and processes. What is the data, processes, and what is the data quality? What are the system landscapes that are there? So discovery is important. Without doing the discovery, you cannot say that now I'm going to up your ROI by 2 times or 3 times, or I'm going to up your revenue by 2 or 3 times. You won't be able to quantify it because probably you might not have the data. If you do not have the data, then you need to bring in again a data team wherein the team can supplement and complement the data, and those data elements need to be verified. So stage 1 is always a discovery of as-is data and processes, whatever the processes that are running in it. And then stage 2 is, once you discover that, you go through a data health check, data health assessment, data completeness, whatever you call, data profiling. And then you would know that whether the data is good enough to be utilized in the program, good enough to build the systems, good enough to build the BI, good enough for the machine learning or AI, all of that. And today the biggest challenge, if you see the reasons why the programs are failing, and especially the machine learning models are failing, is lack of data. And that's why the industry has introduced synthetic data, so that at least you can train with the synthetic data, and then when you get to the real data, at least it is similar. So you have to curate the data. So the data health assessment is vital for any CDO to do. Be it even 100,000 records, or be it 1 million records or billion records, you need to check the completeness of that. And many a times we have seen, or I have personally also seen with my team, is that the ERPs are not configured in such a way that it generates those transactional data using the master data. Many a times you miss that. So you need to go back also to the basics of it and go and reconfigure the stuff. And again, one of the other challenges that industry is facing at this point in time is that everybody is buying technology. Like it's a open market, let's go. And the technology companies, okay, not to be taken as an offense, but technology companies, they are giving you the bill of quantity bomb of all the software products, hundreds of products. They sell it, and until next year you get the renewal invoice or license invoice, you would not know that this is what actually you have invested into. My personal opinion is that instead of buying the technology, rent it for a while, do a POC on that, and see that whether the technology is viable or not, whether the technology is feasible or not. If the technology is feasible, then only invest into it. Otherwise, you would invest millions into the technology. And by the way, technology is not going to do anything. It's the data that is going to drive, because it is a data-driven business that you are looking at, not the technology-driven business. Those days are gone where the technology would have done it. Yes, technology will enable, technology will empower, technology will accelerate the growth, but it's not the only contributor there. So again, we have given suggestions and we saved millions of dollars to the organizations where people were just buying the technology, because you buy a ML framework or AI framework, it's not going to help you. And then the third step, what we say is the as-is data analysis, as-is process analysis. Process modeling is important, because even if you would like to know the procure-to-pay process that you want to automate, or source-to-pay process, or hire-to-retire process, there are a lot of things that need to be looked into. And many a times when we had workshops, when we asked the process specialist or the process owner to draw something on the whiteboard, it was only 4 boxes. That's it. Whereas when we finished the project of process modeling, guiding them, it was into hundreds of different processes, level 1, level 2, level 3, level 4, level 5. Because if we do not know how the data is flowing through the processes, then we will not be able to improve anything. And there is a possibility of RPA, robotic process automation. There is a possibility of introducing, AIs. There are a lot of integration points, but until and unless we explore the process modeling, we will not be able to pinpoint where is the improvement needed, what are the value leaks, what are the gaps. That's the third point. And then the fourth one is that you cannot get ROI in a year or 2 years. It's a long-term process, but short-term wins are important, because short-term wins assure the management or the stakeholders or the leadership that there are capabilities within the organization to grow. So look at very, very short term, which is 3 to 6 months, and then 6 to 12 months, and then 12 months beyond 12 months of it. So when we set up any KPIs, let's set it up in such a way that you have short term wins, and then you go to the midterm, and then the long term wins. Long term wins will take time. And I don't know of any organization which is 100% data quality compliant. And we will not get there, because data quality need to be monitored every day. Every day there must be either improvement or it must stay as is. But the moment it is going down, you need to bring up. So for those things, you really need to have the KPIs. And in some organizations, the data stewards have been incentivized, which means that if you improve the data quality month on month or quarter on quarter, you will get these incentives. And those are really the right things, because a CDO will not be able to improve the data quality. CDO will be able to put down only the methodologies, processes, and the measures and the metrics. The data quality need to be contributed by the end users. And only once we have the data quality, we'll be able to move to the next steps. So the process optimization is another one. And then sometimes, we have seen that, I'll give you an example of it. One organization, they said that we would like to now bring in RPA, robotic process automation, and then they built their data sets, they cleaned it and everything, they implemented it, which is the entire procure to pay process was automated. And within a month's time, all the, maybe, about 20% of orders were placed wrong. Why? Because the data quality was wrong. Yes, you really cut a big cake, you celebrated it, but down the line, you are actually losing a lot. So don't touch the functions that are risky. And they were spending about $1 billion a year, which means that maybe 20%, $20 million they were spending on the right stuff. And the orders were placed since it was automated. So instead of going into that kind of fully automation, because everybody wants fully automation, but human intervention is required during the pilot phase in order for us to prove the point, and then only the fully automation, you can go for a fully automation. So that's also the lessons learned. And now that they understand it, they don't implement everything across the group. They go with the pilot. You always test it, and then you move to the next one. And then all the time, business performance measurement is important. We need to measure. And if we do not measure it, the stakeholders, the leadership, nobody is going to believe. And the numbers is what the board is looking at. The numbers is what the shareholders are looking at. The numbers is what everybody is looking at. And we have seen some organizations, they generate the reports of business performance improvement with some numbers thrown, and it's been displayed across the organization so that everybody is aware of this is the change. Because of this change, these were the numbers that actually improved. And then the last but not the least is that orchestrate it. Still, there are a lot of organizations who said that they have digitally transformed, but there is a lot of manual effort involved. So orchestration is something wherein you augment all the methodologies or the technologies, whatever is required for that process to automatically acquire the data, automatically harvest the data, automatically identify the data, whatever the data is, and then move forward. So those are the 7 steps that we have.
Thank you for that, Imad. I just noticed, looking at this, we had CDO conference, and we should learn here. So yesterday, I saw a guy putting up step 8.
Oh.
He said monetize.
Oh,
You see, so
Agree.
let's just
Agree.
check in. So we'll add one and say monetize.
Absolutely.
That becomes a big
Absolutely.
story here, it
Yeah.
seems to me. But I'm just checking the time. I think you covered a lot. If we get this masses of data in, and we say we need to stick to the basics,
right,
we cannot get away from this.
right.
The one question that just came to mind, and that leads on to some of the topics. Last year, I did a presentation with Reach, and that was on the data washing machine.
Right.
Now, some of the work that we're doing here with the universities is the whole engines for entity resolution. Like you say, there's lots and lots of
Right.
tools and tools and tools.
Right.
So entity resolution is one. The automatic washing machine is like you want to put a couple of knobs.
Right.
Your example of automation.
Right.
You want to walk away and you want to get this clean stuff. And it seems to me that won't happen. So my question, taking what's coming up with the whole quantum world, whichever models is going to win
Right.
and play out in future, and dump this masses of data, do you have any view from our expertise what the role of ontologies
Yeah.
and sort of basis of hierarchies and actually trusted values will be, just to bring sanity, if we want to automate that, and to what extent should the CDO actually
Right.
be adopting that? You've got
Right.
any views on that?
Yeah, absolutely. See, now the CDO is looking at all the different types of data objects. Now, the important thing is metadata. I think, within this symposium, we could see only one metadata session. But actually, metadata is important. The data about data, the data dictionaries talking about it, ontologies, the taxonomies of it, what defines it. Probably it's very easy in case of business partner where customer, vendor, employee, and chart of accounts and some of the other stuff is easily doable with a limited metadata. But if you go into a asset centric, heavy asset driven industries, the metadata of all the equipments, the metadata of all the materials, spare parts, the services, maintenance plans, and that's actually a massive thing. So the ontologies are actually contributing a lot. And today, if you look at it, there's only one standard that is supporting this, which is ISO 8000 standard. And the principles of ISO 8000 standard still are applicable whether you apply it onto the quantum computing.
Thank you for that. So I'll have a job.
Yeah, or you apply it onto anything else, but the ISO 8000 is something. And there is very, very, less awareness about it. It's very least standard I'm sure everybody is, aware of. So ISO 8000 standard is evolving, and supporting standards are 22745 is there, 29002 is there, and all these standards. I mean, let me just give you another analogy. Why are all the accounting practices around the globe are same? Because they apply a standard. Standards bring in consistency, standards bring in transparency and all of that. For data, are there any standards? That's what is also the question many times we have been asked. There is a standard, but are people using it? They are not using it yet. But until and unless we use the standards, ISO 8000, ISO 22745, 29002, all these other standards that are complementing it, we will not be able to have a foundation of the data. Because all these standards are talking about metadata, all these standards are talking about master data. So if you look at the stack of it, if your metadata is wrong, your master data will go wrong 100%. And master data is wrong, your transaction data would go wrong. And what we are doing, what all these days the experts are doing is that they buy a BI tool and they run everything on the transactional data. But transaction data itself is wrong. So you cannot get to the analytics without having the right transaction data. To have right transaction data, you need to have the right master and metadata. And the foundations have been left, and because we are bombarded with all the technologies, all the buzzwords, all the methodologies. But my take is that ISO 8000 can address several of these things because it is evolving. It's not something that is discontinued or inactive. It is evolving, and that can help establish the data quality.
I think so, especially because it's going into the what is the secure systems that we're getting right now? Encrypted.
Yeah.
It's getting into that. Yeah. It's getting into that. So. I'm just checking. I mean, we can talk, but maybe there's some questions that it's.
Obviously, if you have questions, you can post it. We will definitely respond. There are.
Thank you for your talk so far. I have a question. We're used to governing and managing and regulating around domains, right? This is, some sort of a regulation. But one of the topics you brought up is just bleeding edge, that brain to machine interface. You're slowly getting into thoughts about what you did, thoughts about what you might do, and thoughts that, thank God, we choose not to do because we're rational human beings, right? But that could be all over the place in data. Where do you see the role of the CDO and the regulators in that sort of data domain?
Want to take a stab at that? But again, because it's all over the show, I think the safety net would be where we are as humans. Because I think we're sitting this, if you look at some of that, if that's what you were hinting on, we get these transplants, and all of a sudden you would be able to communicate with a machine. I think it will be a short step with another human being, exchanging thoughts.
Right.
And that's where it's heading, So I think that's the scary part, which probably we're not ready for it. So maybe we need to park the safe haven, my little secrets, and I put it in a digital box and give you a reader, and then you read what I think you should be reading. But I think that's going to go away. I think if you really say where it's going, it's interesting when I saw Musk investing into Neuralink. That guy's got an idea. I mean, he didn't go to space just to show NASA it could be done cheaper. It's about control. And I think we're heading there. So again, the question on the data side, I think Imad can touch on it, but I think we'll have to work through the quality side of my thinking. But it's coming.
It's not just the quality, it's the compliance and
Compliance
the
and
governance.
regulatory
Exactly.
requirements.
Exactly.
One of these good quantum computers breaks your encryption and now gets whatever you came out of. It's
Right.
interesting.
Just a comment. Thank you, by the way. So, listening to you, one of the challenges I have is just trying to build new data pipelines for these powerful analytics engines. So now my analytics engines are more powerful than ever before, right? I've got predictive algorithms that are now a commodity. I can buy a library and they're easy to access and they're fast and they scale. I'm trying to feed those capabilities today, and it's hard to bring data to those capabilities. So just when I feel like I'm getting close, you guys come and say, that's nothing, right? I'm about to, what did you say, 40 times, 100 times? The analytics is going to get even stronger.
Yeah.
So I'm thinking, how in the world am I going to get, I can barely feed the power I have today. How am I going to feed that power that's going to demand it tomorrow?
Yeah. I think, and I do some bike riding, and one of the trips was going down in South Africa into the hell. That's where, for some years, many years, people lived there. But here's the shocking thing. For 100 years, people could live in that, in isolation, without exposure to the rest of the world, until a bulldozer came. So a bulldozer came later, and it took a guy some time to actually get a road down there. And now it's open, so we can go down there. So the man-machine interface was, is the bulldozer bad? Should the guys be there 100 years? Or the bulldozer is actually good, but it has to be managed. So I think what you're stating is, if you look at this is frightening. When I discovered, the quantum computing, and it's here, 158 million times faster. Are we going to be able to cope with it? Forget about it. Are we bulldozers? No. But we'll have to know the levers of the bulldozer. And I think that's where the challenge is, and what Imad is displaying. We need to get into this and be in charge of it. Like the science fictions. Are the machines going to control us, or are we going to control the machines? And I think it becomes a question in what you're saying.
Yeah.
Great stuff on the quantum computing. I was waiting for you to go into the multiverse there for a second. Thanks for not going there. Question for you on, I don't know, it seems like there's a giant gap between what CDOs are currently worried about. I speak with tons of CEOs that are still like trying to get into governance. And we've had how many decades of AI, and companies still are, there's a handful of companies that truly have that figured out. When realistically does quantum computing come into play for what a CDO is going to be worried about? And then after you answer that one, isn't this a nuclear change? This will change how governments are run, cybersecurity.
Yeah.
On the FinServ side, you win. If you're the only bank on the street that has this, you win.
Yeah.
And it's unfair. So, a couple questions.
Whether it's unfair or not, last year I was reporting because I did some research, and it was hidden research. There was a paper from Trump's time on quantum computing, or quantum. It was written. I could draw this thing down and I had a look at it. And they were talking about a quantum financial system. And if you look at the details of that, which is banking, which is actually my example of the bulldozer, who's in control of the levers of this mighty machine. People with shovels can't do it anymore. So the whole banking system of that is, who are these guys in between? Charging me, controlling me, decide what I can do where, compared to, the whole blockchain, and crypto. I think it's coming, and we need to have the right tools to actually, if I want to deal with you, what's the value? Let's do it, because it's between you and me. And I think it's like, and that's why I pulled this analogy of the CDO. It took us 40 years, or not 20 years, last years. And like you say, we haven't moved because we sit with this inertia. But quantum is going to push us immediately, because it's just going to dawn. And we'll have to adapt or die. But good. let's move that. And I think that was the whole purpose of this, was to bring the awareness and say, hey guys, there's more to this than just, fiddling around and have some meals here.
Right.
Thank you for
I
that.
think we're out of time. Thank you guys very much. Great presentation.